after we have done the perform analysis and finding out that there are no more errors in our model, we are now ready to perform the design process. So for design, click this tab, then click concrete and choose ACI code. But before that, let us group first all the concrete elements and all the steel elements. So I will click all the concrete elements here. Select all the concrete elements. Actually, the entire thing below is concrete, except for a few members at the roof level. So let us carefully select those members. Okay, so here these are the concrete members. Alright, there are still some unselected members, so let's be careful to select all of them. Okay, here. Alright, so to group all the concrete members, let's do Control G and then create let's say concrete elements. So let's say concrete, then okay, then associate to selected geometry. Alright, then after that one, view selected objects only. Okay, to be sure if your selections are all correct, you can select everything here and then using the 3D viewer you can check if you have correctly selected all the concrete elements. Alright, so next is we now define the parameters. The FC prime, this one is 3000 psi or roughly 21,000 kilopascal. So let's add that one. Next is Fy, that is 414 megapascals or grade 60, add. Secondary, that is 275 megapascals or grade 40. Then for the maximum main member for column, let's have that one as 25. And for minimum, let's have that one as 20. For the beam, let's have the maximum as 16. Now we limit all the beam design to 16 mm only. Then for the secondary members, let's have the minimum at 12. 10. Add. Okay, so let's try to check. We have the code is ACI, FC is 21,000, Fy main is 414, Fy secondary is 275,000. Then for the maximum main, 25. Then we have the minimum main For the columns, 20. Then maximum main for beams is 16, and minimum main members for beam is also 16. So it means to say that we are limiting the design of beams to 16 mm diameter only. For the minimum secondary members, that is for the column ties and the stirrups, we have 10 mm. Alright, so let us now assign this one to all of the members here. So for the FC, let us assign to view. For the FY, let us also assign to view. For the FY secondary, assign to view again. For the columns, the maximum main, let us select only members parallel to y-axis, so that we can only select for the columns. So assign to selected beams. Assign, yes. Then for the minimum main, select again beams parallel to y-axis. So minimum main, assign to selected beams, yes. Now for beams, let us select now the horizontal members. So let us select inverse beam selection, so that instead of the members oriented in the y-axis, it will select the members oriented in the horizontal axis, meaning the x and z axis. Okay, so it already selected the members that are horizontal and not vertical. Okay, let me just do that again. So select by inverse beam selection. Then to be sure, let us have select view selected objects only. So the maximum main, assign to view. Then the minimum main, assign to view as well. Then minimum secondary, assign to view. Alright, so let us enable the column again. So view everything. And to avoid viewing the trusses, you can do Control G, and then concrete, then highlight all the concrete elements, then view selected objects only. Okay, so we have placed all the parameters. Now we are ready to place the command design beam, design column. So for the design column, let us select again the beams parallel to y-axis, and then assign to selected beams. Then for the beams, select by inverse. So we are selecting the members which were not selected before. So view selected objects only, then design beam, then assign to view. Yes. So we have already placed all the parameters, and we have issued the command design beam and design column. So all that's left is to run the analysis again. And let us now see if the design has been performed. So let's say you select this column. There is a tab here which says concrete design. If you click that one, you can already see that STAAD is performing the design and arranging the rebars according to what has been calculated. So we have here 1, 2, 3, 4, 4 on all 4 sides. So therefore, there are 12 rebars. Okay, you can select the members and check all the design results. Okay, for the beam, you can also see here design of the beam. Then you can also view the output viewer and you can see the results for concrete design. So let's say beam number 46, you have here all the design results. Okay, so this is a very lengthy report, but if you are already well versed in STAAD, you will look at the analysis and then look for the similar or for the members with similar results for shear and moment, and then you can only design the part which you want to design and maybe copy that design to all the other similar members. Okay, let's say for the column, you can only design the worst case scenario for all the columns in this array. Here, you can have one design for this set of columns, one design for this set of columns, and another design for this set of columns. So it's up to you how you organize your design process. All you have to do is to select. Okay, make sure that when you design the column, you will only select those columns that have the most critical shear and moment or stresses based on your evaluation of the analysis result. Okay, so let's say if this is your shear and moment diagram, say beam forces, then you will see what are the most stressed members among all the group of members. Let's say for the C1 here, you will only select the most stressed C1 and then select that one as your design element. Okay, so you can only pick one for this column, another one here, and another one for this part. Alright, so I hope you learned something with our tutorial for STAAD modeling of structure. Thank you very much.